Good morning, my dear students. In this video, I am going to discuss the various models including ARCH, GARCH, TARCH, EGARCH, PARCH, FIGARCH and FIGARCH models. And there are two parts of this lecture. In the part 1, I am going to present introduction and estimation of this model, and then in the second video, that is video number 339, I'll discuss in detail the estimation and interpretation of these models. So, ladies and gentlemen, let me start with the introduction. I have already discussed this in my previous videos, but once again I'll show this to you. This is introduction to volatility, and these are its various points. Now let me start with the graph of the stock price of Pakistan Petroleum Limited, and the data covers period from January 2012 up to 2020, and this is the graph. This graph shows that there are certain periods in which there is a high volatility and they are riskier than others. To understand it, suppose an investor wants to invest in stock in time period T and wants to sell it in time period T plus 1, that is the next period. In this situation, the forecast of the rate of return only will not be sufficient. The investor will be interested to know the variance of the return over the holding period. The unconditional variance is of no use here. To estimate the riskiness of the asset at a certain time period, the investor will examine the behavior of the conditional variance. Now, regarding the ARCH family, these models model the behavior of conditional variance or conditional heteroscedasticity, which determines the CH part of ARCH model, that is the conditional heteroscedasticity part of the ARCH models. This is the introduction of the ARCH model. ARCH represents auto-conditional heteroscedasticity, and these are used to describe a changing, possibly volatile variance. These models were created in the context of econometrics and finance problems having to do with the amount that investments or stocks increase or decrease per unit of time, per period of time. ARCH model could be used only for any series that has periods of increased or decreased variance. And these models were developed by Angel in 1982. Sample and sample period. This is daily stock price of Pakistan Petroleum Limited from 2012 to 2020. And this is the description of the model. This is a type of ARCH1 process. The ARCH1 will simultaneously model the mean and the variance of the series with the following specification. So equation number 1 is mean equation and equation number 2 is the variance equation. This model shows that when a big shock happens in T-1 period, the value of UT will also be bigger. The conditional variance cannot depend only on one lag period but on more than one, for each case producing a different ARCH process, that is ARCH2 process will be like this, and in general the ARCH-Q process will be given as follows, and that is shown by equation number 4 and 5. Testing for ARCH effects. The presence of ARCH effect is required to be tested to know which model requires ARCH estimation instead of OLS. Now, how to estimate ARCH model? Time series data required to check stationarity first by applying unit root test. In this table, we see that this is the unit root test of the variable open, that is the start price, and the p-value shows that this series has a unit root at 1%, 5% and 10% level. Then when we take the first difference and we test for a unit root, then p-value is 0.00, so we now reject the null hypothesis that the series open in first difference has a unit, so there is now no unit root and the series is now stationary. So the first step is to estimate AR1 model. The results are of no interest in themselves, so we would want to know whether there are ARCH effects in the residuals of the model or not. So this is the regression of the open series in difference form on its lake value, but this is of no interest. So we will test for ARCH in Eviews, and here is the procedure how to do it. On the equation toolbar, we will click on view and then residual diagnostic, and then we will click on heteroscedasticity, and then we will click on ARCH, and then we will click OK, and then we have these results. And this p-value of the observed R square with chi-square 1 degree of freedom shows that there are arch effects. So the result shows that the observed R squared value is 134.51 and statistically is significant, which indicates the rejection of null hypothesis of homoscedasticity, and we conclude that ARCH1 effects are present in this model. And this is how we estimate the ARCH model. We will click on estimate and then equation specification and then quick estimate equation, and we will click on ARC option, and then we will have these results. So there is the mean equation, and there is the variance equation, and this is the conditional variance graph. We will click on view and then graphs and GARCH graphs and then conditional variance, and we will have this. Now the ARCH model looked like a moving average specification then as compared to autoregressive, which was a drawback. A new lagged conditional variance was included in the model as autoregressive term. This idea was worked by Boleslev in 1986 in his article, which is given here, and it introduced a new family of GARCH models. This is GARCH PQ model, and it has the following function. And this is estimation, how we estimate GARCH models in Eviews. These are the GARCH results. So here we see there are GARCH in lagged value, and all these are significant based on Z statistics, but in the mean equation, the lagged value of the difference of the series is not significant. The R squared value is minus 0.007 and the Durbin-Watson is 2.27. So this is the mean equation and this is the variance equation, and these are the t values in the parenthesis, and this is the interpretation. If the sum of the two coefficients in various equation is close to 1, it indicates persistence of volatility for a given shock. A value of 1 indicates integrated GARCH process and that shocks have a permanent effect on volatility. This is the conditional variance graph, and this is TARCH or T-GARCH model, and this is one of the restrictions of ARCH-GARCH is that they are symmetric, because what matters is the absolute value of the innovation and not its sign, because the residual term is squared. Therefore, a positive and negative shock will have the same effect on volatility of series. The threshold GARCH model was introduced by Zekoyin in 1990 and Glosten et al. In 1993, and the aim of this model is to capture the asymmetries in terms of the negative and positive shocks. So this is the good news, and if gamma plus theta is bad news impact, if theta is 0, the news impact is symmetric, otherwise asymmetric. So this is how we estimate the T-GARCH, and this is the actual estimation. Value in parentheses are the Z statistics, which shows the coefficients are highly significant. This is the estimation of T-GARCH model results. This is the interpretation. 0.48 shows the estimation of positive shock in the model. Minus 0.3106 is the coefficient for existence of asymmetry, and negative shock at both the coefficient 0.48 minus 0.3106, that is equal to gamma plus theta is greater than gamma, so then bad news has greater effect on than the good news. Then we have the EGARCH model, that is exponential GARCH model, which was developed by Nelson in 1991, and the variance equation of the EGARCH is given as follows. The left hand side shows the log of the variance of the series. It makes the leverage effect exponential rather than quadratic, so the estimates of the conditional variance will be non-negative. And this is the estimation results of the EGARCH model. And this is about diagnostic tests for the model. This is the normality test, and based on the Jarka-Bera test value of 308,259.9 and p-value of 0.00, it means that this model does not follow normality. This is the test for serial correlation, and this is the actual ARCH LM test, and it shows that there are no ARCH effect up to Q terms based on these values of 0.1747, and these are the references which were used for making this presentation. Ladies and gentlemen, this was the theory and estimation and interpretation of various ARCH family models, including ARCH, GARCH, EGARCH, TARCH, and so on. Thank you very much for watching this video. I hope this was informative for you. Kindly do share this video with your friends, with your colleagues, and with your students, so that they may also get benefit of this information. Thank you for your attention, and if you haven't yet subscribed this channel, kindly do subscribe, and do not forget to click on bell icon so that you can get notification about other videos that I'll upload for you. Thanks for watching my video, and see you in another video.